study to more comprehensive the tree adaptation in anthropoid environment. So we can know that urban green space plays a crucial role in mitigating the diverse negative effects of urbanization. But in this study, we want to focus to the physiological response regarding a specific species, that is Quercus ilex, that are typical species used very often in planification on Mediterranean city. So this study aimed to identify significant correlation between photonics parameters and soil quality through Quercus ilex, but this method is possible also to apply in several species. Also, we want to develop a predictive model that integrates both data set for a more comprehensive assessment, accurate assessment of urban tree adaptation, and propose guidelines for urban green management that consider also the role of soil in management of green space. So this is our instruments that we decided to select to conduct our analysis and to regarding the physiological response in Quercus ilex. So we use Raman to analyze the primary metabolism, so chlorophyll and carotenoid, the dual X-force A to analyze the primary and the secondary metabolism, and finally the green seeker to analyze NDVI. So we choose three different areas because we want to study three different levels of pressure, anthropic pressure. So we have the urban center in Cagliari, suburban periphery in Monserrato, and rural control zone in Seul. For a total of in each area we select 6 species for exemplar for a total of 18 Quercus ilex. So this sampling strategy allowed us to assess the vegetation physiological response to varying levels of environmental stress, test the effectiveness of measurement tools in heterogeneous environmental setting, and also obtain comparable data across areas with different anthropogenic pressures. So this typical approach was based on dual validation level, instrumental validation and environmental validation. So regarding the methodology, we can say that for physiological response, not destructive optical measurements were taken on 20 leaves for each tree. And regarding the soil analysis, it was conducted at the base of each tree at a depth of 50 centimeters that represents the most activity root zone for the study species. So we can see for the response regarding logical response analyzed through our optical tools. So we for the first step, we can see how the Quercus ilex product high level of chlorophyll, but this is a typical mechanism compensatory of regarding this species when it put in the ambient, in the habitat with a middle level of pollution. But the strange things regarding our control zone. So we can see that in Seul we have a high production of NBI and high production on carotenoid and polyphenols that are defensive pigment. So this is impossible for us to justify study parameters, atmospheric parameters and atmospheric pollution. So in this case, we have to choose to investigate the role of soils in this behavior for justify this behavior. So this is also the response of physical adaptation of our species. So we can see that this strategy reflects a trade-off. So the plant sacrificed rapid growth in favor of survival under adverse conditions. This is testimoniated also the tolerance and the resistance of this species. This is because it's very used in Mediterranean area. Okay, regarding our analysis soil, we found in Cagliari several kind of soil. So we decided to put all the sample into two kind of soil, so soil A and soil B. Instead, in Monserrato, we found a homogeneous area, and this is allowed us to put every sample in a unique single soil, named soil C, and the same things happened in Seoul, where we found a uniform context, so we allowed us to put all our sample in the unique soil D, the name is soil D. So this composite sampling approach provided dual benefits: preserved the distinctive characteristic of each zone while maintaining data representativeness, and also optimized analytical process without compromise data reliability by reducing laboratory analysis, minimizing localized error, and balancing heterogeneity and efficiency. So this is some images regarding our field measurement campaign, and also our laboratory analysis that it was conducted at the University of Cagliari with Professor Andrea Vacca. Okay, this is an example of our tables that represent the physiochemical properties of our four soil A, B, C, D. So we can see an extract of our table. So we can see the nutrient availability: calcium, magnesium, potassium, sodium, but this table include chemical properties, nutrient availability, of course, water retention parameters, and heavy metal concentration. So we see that for each physiochemical properties of the soil, there are different response, different physical and physiological response. This is because we choose for each parameter to report only the parameters that have high correlation value. So this is the table. Instead represents the Pearson correlation matrix quantifies the relationship between this edaphic factor and plant response through four distinct levels. So vegetative metrics, leaf morphological characteristic, physiological indicator, and also secondary metabolity. So this method reinforces the value of multidisciplinary method in urban vegetation management, because the data analyzed for ilex reveals strong correlation between soil characteristics and various optical parameters measured in the leaf. So we can see that if the soil is to reach inorganic carbon, nitrogen, chlorophyll production may decrease. Also, the quercus product fewer flavonoids in calcareous soil and organic rich soil. So the presence of carbonate also inhibits synthesis by reducing the availability of essential micronutrients. And instead, a small amount of nickel, also chromium, actually help plant process nitrogen more efficiently. So plant photosynthesize also better in slightly alkaline soils and produce more carotenoids in soil rich in carbon, nitrogen, that help protect them from the sunlight, much sunlight. And finally, regarding polyphenols, plant products more polyphenols in calcareous soil and rich in organic matter. So summarizing, we can see that calcareous rich soil reduce some natural defense but increase polyphenols, and this is our case is in Seoul, that it was our organic matter and nitrogen promote carotenoids, and this is happened also in our control zone. And this change regarding also the level of heavy metal. So nickel can be benefiting, increasing chlorophyll, and also chromium harms the plant by reducing chlorophyll. So this consistency between physical soil data and the physiological response analyzed via photonic data is the key result. So this correlation demonstrated for the first time how such change can be effectively monitored using innovation photonic approach. So the next step regarding the advanced statistical analysis, so through multivariate statistic models to determine which parameters most significantly influence the observed physiological adaptation, correlation tests to assess whatever variation in leaf pigment are more strongly linked to air quality or the soil property, and finally interaction analysis to understand whether combined effect between soil and air modulated plant response. So in conclusion, this study demonstrated the importance of photonics technologies in study of urban green space, and also the importance of soils in assessment of green space. And actually, we hypothesized also to use the Raman not only to understand how the plant responds to the environmental parameters, but also to study the role of the soil through directly with we use the technology photonics. And so thank you for your attention.
Thank you, Francesca. There are questions? Curiosity about this? One curiosity.
Yeah.
In the future,
Yeah.
can you think to use also multispectral images or no?
Yeah.
Because in this research,
It's proximal measurement, yes, of course. Yes, we want you.
Especially for NDVI.
Yes, absolutely. Also to put in confront this the same measurement through proximal and the remote
sensing.
Yeah, yeah.
Okay, thank you, Francesca. Thank you for your presentation very, very fast. And the next presentation is mine.
Yeah. We were discussing
Okay. The next presentation. Okay. Okay. The next presentation, the title is Mapping of the Multi-Risk Analysis for the Cultural Heritage of Sardinia from the Pre-Neuralgic and Neuralgic Periods, Initial Results of the Retarn Project. The author are Enrica Vecchi, Marco Cigagna, Donatella Fiorino, Battista Grosso, Elisa Pilia, Francesco Pinna e Giuseppina Vacca. The speaker is Giuseppina Vacca. Okay. This presentation is about the first result of the Return project. The Return project, the meaning of the Return is multi-risk science for resilient communities under a changing climate. And this project is funded by European Union through the National Recovery and Resilience Plan. It's a very important project because the aim is to study the vulnerability of the cultural and historical heritage due the effect of the climate change. In particular, the effect of particularly hazard as hydraulic, landslides, wildfire, and seismic hazard. In scientific literature, there are a lot of the research about the vulnerability of the cultural heritage. But in Sardinia, there is a very important cultural heritage in a specific period, pre-neuralgic and neuralgic period. The other research is about the vulnerability of the cultural heritage in the medieval and modern period. But our study focalized about the cultural heritage in the neuralgic period. In this picture, you can see a particular monument in the neuralgic period called Nuraghe. And Sardinia is in the map, this, and we are here. Okay, the first step for us was to identify a monument in Sardinia in this period. In Sardinia, there are two big databases about cultural heritage in this period, Sardinia Archeologica and ARNet. We created only one database from these two data sources, Sardinia Archeologica and NARNet. And we created one database with a total of 7,335 monuments located in Sardinia. In this table, you can see the typology of this monument: Nuraghi, Jan's Tomb, Domus de Janas, Menhir, and so on. And in this picture, you can see the distribution on the Sardinia place. The second step after to create the database was to divide those monuments based on their geometry and dimension. In particular, in this table, you can see the different typology of monuments and the geometry that we choose for each typology. For example, Nuraghe complex as the picture that you saw before, the geometry was equidimensional. Okay, or for example, Domus de Janas subterranean, because Domus de Janas in this picture you can see here, and is a monument under the terrain. So, for example, the Nuraghe equidimensional, another monument called Dolman was inserted in the category tall. The second step was to classify the monument based on the material, the construction materials. The construction material, we took from the lithologic map. The lithologic map from the Sardinia Geoportale. And for each monument, we assign the material from the lithologic maps. So at final, we divided in 5 classes of materials, and for each class, for each monument, we attributed the class corresponding. In this picture, you can see the distribution of the monument based on the material. So, based on geometry and construction materials, we define 2 types of vulnerability. 5-level classification for each vulnerability, from very low and very high to very high, and for each hazard that we study, we assign the vulnerability. The hazard that vulnerability choose for each hazard, for each type of material. And in the table on the right, the vulnerability choose for each type of geometry of the monument. For example, if we have neuralgic monuments, for example, the classification of geometry is 5.3. For the hazard hydraulic, this monument has a vulnerability 2. For the landslide, 2. For the wildfire, also again 2, and 2 for the seismic. In base of the material, the vulnerability is, for example, the monument was built in granite. The vulnerability for hydraulic hazard is 1, for the landslide 2, for the wildfire 1, and for the seismic 2. So, but each hazard has a different intensity level, and the intensity level for hydraulic, landslide, and wildfire, the range is between 0 to 4, so 5 intensity level. And this intensity level we took from the maps of the hydraulic hazard, landslide hazard, and wildfire hazard. Only for the seismic hazard we use the value 1, because Sardinia isn't a seismic zone. So on this intensity level, vulnerability of geometry and vulnerability of material, we can calculate the risk for each monument, for each hazard. And this risk, the value is from 0 to maximum 100. but to simplify the representation in the map, we normalize this value in 5 categories, with risk very low, low, medium, high, and very high. This vary for each hazard. So every monument has a risk for the hydraulic hazard, for the landslide hazard, and so on. In this map, you can see the distribution of this risk, in particular on the left, hydraulic risk for each monument. And you can see the risk for hydraulic for the monument are low and very low. Only some monuments are hydraulic risk high. But there isn't a monument with a hydraulic risk very high. And this on the right, the landslide risk, and in this slide, you can see the wildfire risk and the seismic risk. But to assign not for a risk for each hazard, but only one risk for monument, we calculate the multi-risk for each monument, where the multi-risk we choose to choose the maximum value of the single risk of hazard. And in this picture, you can see the distribution of the multi-risk for each monument. In the same case, we calculated the multi-risk map for the municipalities. For each municipality, we choose the maximum risk value for all monuments that belong in this municipality. And in this map, you can see five municipalities with almost one monument with, in this case, high multi-risk. So, in conclusion, the results are not surprising, because this monument have lasted over 3,000 years. But for us, it's very important the methodology for the vulnerability, for the cultural heritage due the climate change. So this methodology we can apply for the other period, other monuments. But the research carry on. The group is very multidisciplinary because there are different professor expert in different thematic. Yesterday, the group were in Torralba to survey Nuraghe Longo. In this survey, there were Enrica Vecchia, Marco Cigagna, that with me we are an expert in geomatic survey and 3D model. Francesco Pinna and Battista Grosso are expert in material analysis, and in the group there are Donatella Fiorino and Elisa Pidia, expert professor in restoration and management. So in the next month there are also the result of the study on a single monument. Okay, that's all, and thank you for your attention. There are questions?
One question, me? Can I? Giuseppina?
Yes, at the moment. Patrizia?
Yeah, only curiosity, in the hydraulic risk map,
Yes.
I see almost a monument with a high risk very near to other monument with the low risk value, no? The pointed, the red point.
Yeah? Okay, yes.
And I think, I don't know, I think that the hydraulic risk is linked to the geomorphological and topographic elements in the area, no? I don't know how you can explain that very near monuments have a different hydraulic risk in this case.
Yes. Sara, possiamo riprendere? Non so qual è. Sì, faccio io.
Yes, it's yes, it's this.
Okay. This?
Yeah.
This? Okay. Yes. We have some monuments with high risk because the vulnerability is about the material and the geometry. But in this case, probably I don't know because I see the database, but I think that these monuments are the material is probably calcare.
Okay,
and so for the hydraulic, the level, intensity level of hydraulic is very high, and the material is the material that sensible to the water.
Okay. Thanks a lot.
Thank you. Another question?
Maybe just a small one on the methodology. So at the end of the process, basically, you classify the different vulnerabilities in 5 classes. Should I speak louder? Yeah. So you classified the vulnerabilities in 5 classes.
Yes.
I was wondering why did you choose to use equal breaks, so from 0 to 20, 20, 40, and so on,
Okay.
instead of, for instance,
So especially this classification chosen to the professor of restoration. So based on the material or the vulnerability is from very low to very high. Based on the damage of this hazard.
no,
In general.
this is clear.
Okay.
It's just about, let's say, the final classification.
Yeah.
So when using
The risk?
yeah, from 0 to 100. So,
the risk.
Yeah, yes,
Not
yes.
vulnerability.
No,
The risk.
sorry.
Yes, the risk. Okay.
yeah.
This?
Mhm.
Okay.
So I was just wondering, did you maybe breaks for instance, natural breaks or quantize, just to see how the distribution would change in terms of number of high vulnerable buildings or low vulnerable and so on.
But this classification?
Yeah.
Okay, yeah. Yes, we have normalized in 5 classes, not specific, very high, because the range between 0 to 100 to correspond to our idea about a risk very low, medium, and so on. Okay, thank you. And now the next presentation is the title is okay. Okay. Towards semi-automatic detection of illegal logging, integrating the optical and satellite imagery with the Stanford field machine data. The author are Gian Domenico De Luca, Lorenzo Arcidiacco, Manuela Colongio, Tiziana De Filippis, Carla Natti, Martino Rogai, and Gianni Picchi. And the speaker is Gian Domenico De Luca, please.
Thank you. Thank you for the nice presentation. I'm Gian Domenico De Luca, researcher at the National Research Council of Italy, Institute of Bioeconomy, Florence, and today I'm showing you some preliminary results concerning the developing of a detection approach for illegal logging using optical and satellite. In particular, this work is within the task 523 of the European Horizon Synthetic project. Just a few words about the project. Synthetic is a project that aims to optimize, develop, and promote wood traceability, starting for each step of the working chain for wood traceability, starting from the standing trees in the wood to the final product, to the final wood product. In this context, the illegal logging alert service is, of course, a key point, a key step in the wood traceability, but also fulfill what are now the actual a new regulation, European regulation and objective for deforestation-free product in Europe. That in fact Europe now prohibit, of course, the importation of the import of wood, of product coming from deforestation, and of course prohibit illegal logging inside. But now the regulation is set. So when we talk about illegal logging in Europe, some problem arise. Why? Because the literature is full about satellite implementation for illegal logging. The problem is that most of this literature is based on tropical forest or forest outside Europe. Outside Europe, the deforestation, the illegal logging is totally different actually. In fact, we need for the first objective is to define what is and what are the modality of illegal logging in Europe. And so the first objective is to standardize the objective, to define and try to understand what is illegal logging in Europe. The second issue that arises generally is the lacking data. In fact, when we talk about illegal logging, the problem are the field data to train and validate classification models. The third problem is the characterization of satellite data, so remote sensing data related to the information that we have collected in the first two phases. So let's see the workflow to try to face this problem, these issues. This is the main workflow concerning the illegal logging detection that is the objective of the project at the end of the project. For now, and the preliminary results that I'm showing you today is the first part, this part, that represent, of course, the three issues that you saw the slide before. So defining what is illegal logging, collecting of the satellite data, and start to understand the response of illegal logging in Europe in terms of satellite information, satellite signal, and the implementation, the integration of field data machine. Starting from satellite data. Satellite data, we use, in this case, we are trying to use Sentinel-1 and Sentinel-2 are the two well-known satellite constellations because are provided by the European Space Agency, are free available, are in the Copernicus is the main constellation is the Copernicus mission. Here you can see the characteristic of the satellite. The Sentinel-1 is at C-band, as a radar band. We used both polarization, vertical edge, and we use differentiating the analysis for both for each of the two polarization. And the last plot is concern the pre-processing of the data, but I don't go more in depth. For the Sentinel-2, we use for the analysis that I'm showing here today just the red band and the near infrared band, two bands that are 10 meters of ground sample distance native. The native ground GSD is 10 meters. In order to construct, to calculate the normalized difference in vegetation index, that is the well-known vegetation index, spectral index that is very, very related to the response of vegetation. So we are collecting temporal time series of these two satellites for now. And what are the characteristics of why we are integrating these two information? The first one is that Sentinel-1 and Sentinel-2 are two different information. One, multispectral, is more related to the physical, chemical response of the vegetation. SAR is more sensitive to the structure of the vegetation. Another thing is that, of course, are free available, high temporal resolution, high spatial resolution relative because it's 10 meters for both. But another reason is that we would like to construct this kind of application for the entire Europe. At least for now, the target nation, the target country is Romania, but we are collecting data from the entire Europe, and in the future we would like to apply this application for the entire Europe. The problem, so what is that when we talk of monitoring in general environment, so when we talk about Earth observation, the problem is that SAR is the optical, so multispectral is sensitive to cloud cover. SAR is not. So of course, when we try to apply this application, this kind of remote sensing in north of Europe, for example, we can't trust on optical data. In fact, today I'm showing you the three study areas that are, one is in Scotland, and the two other study areas are in Spain. Here in this slide, it's time to explain you why I've said the difference between European illegal logging and, for example, tropical illegal logging. Why? Because in tropical area, for example, I talk about tropical area because it's the most famous, and in literature the literature is full about tropical forests. In tropical area, it's easy to see this kind of deforestation. This is deforestation, illegal logging in tropical area. So clear cutting. Clear cutting is an area where everything is cut. In Europe, it's more like a selective logging. Selective logging is a practice that is used, is legal actually, but how it works in terms of illegal logging in Europe? In Europe, people go to the forest, take some tree, spread it and randomly around an area. It's very rare to see a clear cutting in terms trees stolen through clear cutting in Europe. This is very rare. So for now, and this is a problem. This is a problem from a remote sensing point of view, because in this case it's easy to understand the signal and the response of both the satellite, both SAR and multispectral. In this case, it's very difficult. Consider, for example, here you can see here some pole. This probably, because I'm taking this picture from internet because it's difficult to have an image of selective logging. And this is a very high resolution image. So imagine with a 10 meters per 10 meters, when the resolution is worst. The novelty actually of this approach is not only the definition of illegal logging in Europe, but also the use of field machine data. Field machine data that came principally from machine data, harvesting machine data. Harvesting machine is a machine that now is used principally in the north of Europe, but sometimes also in Italy, depending on the forest. However, in Northern Europe is used in the Central Europe, this kind of machine to cut the trees. What is new? Actually, that now they are equipped with Stanford is a software, so the computer now have all the computers of most of the company that create this kind of machine are using this standard software, the Stanford is. Stanford is a software that takes information from all the sensors that the machine has. For example, of course, the position, that is the first information that we need. After that, also the dendrometric information of the trees, so we can know not only the position, but also the diameter and other characteristics. Sometimes you can see also, you can set also some model, allometric model inside to calculate the volume and other things, other dendrometric characteristics. Another thing is that inside the project we are involved. We have involved also one of the developer of is well-known Arboreal app. Is an app that uses to take information from is used for principally for forest inventory. And now we are optimizing also to give us information about illegal logging. Consider that this app works on iPhone 15 and 16 Pro because are equipped with LiDAR, and so we can take also structure information from the trees on the tracks logged. This is like a citizen science in order to be provided. So operators can go when they go to the forest. They can take the information and give us the information if some illegal logging has happened. So let's see the results. For example, these are the results of Stanford. Some results summarized. For example, from the data we have DBH, that is the diameter at breast height, and the volume of each tree. Here you have just some statistical resume. And these are very important. For us, what is important is the position and the time of the cutting, of the logging. But this is important because if we have also structured information, we can compare and relate to the signal of the satellite. For example, here I'm showing you some example. Here you can see two different cases from two different kind of logging. Clear cutting is well known. We expect this cut after the cutting. This is the vertical line. You can see a fall of the line. This is here we applied an harmonic analysis in order to fit the line, the temporal line, starting from 2019 to 2022. Here the logging happened, and you can see that it's easy here to recognize unique features, because what we need now is to characterize features, temporal features, spatial features to improve the information. Here you can see on the other end the selective logging. The selective logging in terms of mean, for example, here we are talking about optical and DVI. You can see that the mean, nothing seems to be happened, but these squares that are simply the frequency of the number of pixels falling within the range is 0.1 of NDVI, are less concentrated. So this could be, for example, a feature that can be used for classification. On the other hand, the radar data. The radar data is different. For intrinsic characteristics, physical characteristics of the SAR is a difficult signal to be processed. In fact, for the clear cutting is clear. For the selective logging, nothing seems to be not useful actually for our team. But after we saw this, we try to apply another kind of processing. In this case, we didn't fit this is only the SAR data. Now I'm going to explain you. We didn't apply the fit, the harmonic analysis. We used the raw data, temporal data, and we applied just a simple breakpoint detection to understand if also a unsupervised, very simple statistical application can find something in an unsupervised mode. And here you can see VH, and this is the VV. VH, I repeat, are the two polarization of the SAR. The VH is more related to spatial characteristic of the forest. And you can see that in Spain, where the selective logging happened, the model, the breakpoint, found a breakpoint. Why? Because the vertical line is the red dashed line that is the time of logging that we know. And the two area, the blue area and the red area, are the area of that breakpoint detection found. So more or less here is perfect, and is perfect. Of course, here there is Scottish, so the breakpoint you can see the clear cutting is more clear the signal, the temporal line. So we can see that the SAR data can be useful. Now, next work will be the other part of the work. That will be the application, of course, of the classification. Of course, machine learning, because it is the more appropriate in this case. And let's go to the ancillary data, the last slide, because what I show you so far, it's not an application for illegal. The models at the end can't say us this is illegal, this is legal. Can detect for us selective logging and clear cutting actually. After the selective logging has been detected, we need, of course, ancillary information. Ancillary information like logging permits. So for us, this is just an alert detection. After that, we have to use this information ancillary. For example, if the deliverable is for a municipality, a country that can give us forest concession, for example, documentation about logging, or another characteristic. For example, if we have another machine inside. For example, we have constructed our method. The selective logging has been detected in the area, but we know that here there is an harvester, a machine, but we had not information about this. We can assume that if a machine is in the wood, is not illegal, for example. So this is another information that we can put inside of the model. At the end, if no one of these information are how to say collision, we can say careful, because here probably there is a probability that there is a illegal logging. Sorry, first in this slide I was not so in final consideration, I have not too much to say. It's just that for now the Sentinel-1, Sentinel-2 are giving us very optimal, encouraging information. Is a very ambitious project. It's a very ambitious objective, but for us, the main result, the good result, can be also to just define, to put a point, to define what is illegal logging in Europe and what is the response in terms of multispectral and SAR data to this kind of problematic in Europe. And for this, I think I've finished, and thank you for your attention.
Okay. Questions?
Yes.
Well, first of all, thanks for your inspiring presentation. I was wondering, because I'm not into your sector, I mostly work on the urban scale. So of course, when working with NDVI and trees and the detection of index of greenness somehow, there's always a problem also in relation to shadows, for instance. Yeah. Right? So did you also take this into account? Are you taking also into account?
Yes, a very good question actually. Shadow is a problem not only in small scales but also in large scales, because if you consider cities, it depends on the cities, of course, is in a plane. So you have shadows and local shadows, but consider also we had some problem with mountain shadows, so orographic shadows that in the forest. So in forest is more the main problem in radiometric terms. Of course, there are some processing that we can do for it, and the fitting of the harmonic analysis can help on one end, of course, but the shadow actually, in my experience, remain a problem, an issue that is very difficult to manage. It's very difficult. So you have to consider, for example, in another experience of the classification, not related to illegal logging, to consider a shadow like a class sometimes. It depends of the resolution of the objective, but shadow trees, if you have a lot of trained data, a lot of data, consider like a classification, another class, in order to help the classification. This could be one of the that I've already used this kind of how to say trade-off, and it worked. In this case, we didn't, we haven't applied, we haven't tested, because we are another thing is that we are trying to collect data. So before to apply classification and to how to say try to fulfill all the problematics, we are trying to collecting all the data. However, this is a problematic that we will take into account. Yeah. Thank you.
Starting from your experience on the forest, do you think that this approach could be applied in the urban context?
In logging, illegal logging in urban?
Yeah. Because we have many experience, especially in Italy, I think. Yeah. In Europe, perhaps no, but in Italy, yes. and could be interesting to understand.
Actually, it should be easier because you have not a background. The problem is in legal logging, selective logging. You have a background of trees, and after you cut just a trees, the background remains trees. But in urban, if you have only one trees, so we are tracking. Of course, it depends on the. What is illegal? We have to define illegal logging in urban. The first thing, the first option. So there are parks, and urban. There is a difference between urban and peri-urban. Urban inside the parks, urban inside the streets. Because I expect that I assume that the trees are there is an inventory of the trees inside the urban. But if you have some trees and with urban, so a background of concrete, it's easy to understand if something happened because the spectral signature change very fast after.
But it could be also applied not only for for natural capital in some way, but also for buildings or built environment in some way.
Yeah, but built, what is illegal in built?
Buildings could be.
Okay, no, detection of illegal buildings. I think it's more a contextual than spectrum. Because contextual why? Because I think the materials are the same. So if you take a roof of legal and a roof of illegal are the same spectrally. The context. In that case, just to put a map of probably the municipality can give you, for example, all the catastro or something.
It could be practically useful for a municipality to define some policy.
It's just contextual in that case. However, yes, the alert could be the algorithm can be worked, not this of course, but yeah, could be.
Thank you. Yeah.
Okay, last question.
Yeah.
Because we have
I'm happy, absolutely.
Of course.
I'm happy.
Congratulations for your work on the no, I was wondering at the beginning. I was expecting as output like math,
Yeah.
So have you considered to basically specialize these results, but also since you said it's difficult to understand how illegal selective logging works, maybe through a spatial output to detect or maybe structure an inventory of how this illegal let's say logging works. Like you find traces on the maps that maybe tells you, okay, this is an area in which this phenomenon is happening, and maybe.
Somehow I was also going to this because when you look at this from the spatial perspective, and then you add, let's say, some other variables also, like to complement a bit the ancillary aspects that you consider. It means also adding, for instance, what are the morphological conditions where these things can happen, some form like slope or accessibility and so on. This can help somehow also directing the detection of this activity somehow.
Yes, of course. In fact, within the ancillary information will be also morphological information, of course. A lot of information actually, but now I have not a list because we are working on it. It depends. Depend of the scene, because the first thing is to understand the spectral signal. After the spectral signal, we can say we can choose what other input can be put in the second part of the model. And we have also other solution that we can also talk about it after the session, of course, for the time. But yes, we have a lot of idea, and all your comments and questions are very. Thank you for your question because they are very. They took the point.
Carry on the discussion in the coffee break. Okay, thank you. But now we have another presentation. We have two presentations. And I think the speaker is for both
With me?
Patrizia.
Yes.
Okay. And the first presentation, Patrizia.
Yes, you see my.
Okay. Can you put in presentation mode, please?
Okay. Okay, you see?
No.
No? I'm in presentation mode now.
Is it possible to put your presentation in PDF mode? No? Okay, no. Okay.
But you don't see the presentation, or you don't see the...
Yes, the presentation, yes, but not in presentation mode. Full screen.
I'm full screen. Just.
Deve cambiare l'impostazione dalla sua.
Just, I understand why. Okay. We try with this. And now?
No.
No.
Have you? Okay. Yes. Now yes. Okay.
Okay. Good afternoon.
The next presentation, the title is Integrated Mechanical and Electromagnetic Geophysical Imaging of a Complex Aquifer System, the coastal plain in Muravera, East Sardinia, Italy. The authors are Raffaele Martorana, Luca Pirodi, Giampiero Deidda, Alessandra Carolo, and Patrizia Capizzi. And the speaker is Patrizia Capizzi. Please, Patrizia.
Hi, good afternoon to everyone in presence and virtual presence. Today I will share with you the results of our study on integrated mechanical and electromagnetic geophysical imaging, and I present you the case of the coastal plain in Muravera in Sicily. The water scarcity is a major global issue of contemporary times, in large part due to intensive agriculture and industrial use of territories, overpopulation, population, and climate change. Smart communities provide a cultural framework to assess sustainability in natural resource exploitation, protection, and renovation, thanks to management action, which can be especially effective when taking advantage of the knowledge derived from direct and indirect investigation. In the early 2000s, a geophysical surveys using high-resolution reflection, seismic, and time-domain electromagnetics method was carried out in the southeastern part of the island Sardinia in Italy, near the Muravera Plain, near the Mendoza River. The main objective was the study of a very complex coastal aquifer situated in an area where a still present large saltwater intrusion phenomenon was occurred. And very important interventions were planned, like hotels, various buildings for tourism, and overall a dam, just close to the delta of the river Mendoza. The effective management of groundwater is for this area a great importance for tourism, agricultural activities, like a very main resource for the economic growth of this area. So it is vital to distinguish the aquifer subsystem and their saturation with fresh, brackish or salt water, and to know the depth and the morphology of the bedrock. This may be achieved by drilling observation wells, but also using surface geophysical surveys and integrated diagnostic protocols capable of providing multi-physical underground information to constrain the geological reconstruction of the aquifer. The Mendoza river is the biggest river in Sardinia, originating from the Gennargentu Mountains, approximately in the middle of the island and flowing into the Mediterranean Sea on the southern part of the Sardinia east coast. Here we present a simplified geological map of the Muravera Plain, showing the location of seismic and the geophysical profile. Red dot here indicates the geophysical profiles. Line 1 indicates the first seismic reflection and the TDM profile, and the line 2 here corresponds to the second seismic reflection and the time pass profile. Among various geophysical methods, the TDM and seismic reflection techniques were chosen to be the most suitable of the indicated purposes. The application of the TDM method has been widely used for describing the depth and the thickness of coastal aquifers, defining their physical and chemical properties, and assessing marine intrusion pollution levels. The seismic method, vice versa, is very efficient for solving the structural problem, but is unable to recognize the different aquifer properties. Literature studies have demonstrated the goodness of the application of integrated TDM and seismic reflection techniques for a similar purpose of our. The seismic data were acquired using a single 50 Hz geophones attached to a 48-channel seismograph systems with a sample interval of 0.5 milliseconds and a total of record length of 1 second. The geophone, the data were recorded using standard common midpoint roll-along technique, and using a geophone spacing of 5 meters and the source spacing of 10 meters, and to providing coverage with a common midpoint spacing of 2.5 meters for 12-fold common midpoint coverage, and reach a maximum source receiver offset of 245 meters. Here we can see 3 shot getters representative of the seismic data set along the line, the seismic line 1. Reflection are evident above the 600 millisecond in all the shot getter. In record 13, the reflection around the 400 millisecond, the event A, show distorted hyperbolic move out, suggesting a deep move out effect caused probably by a down deep reflector here. And the upper part of the record 29 show the clear fist break here, representing the reverberation arrivals named B, event B. And finally, in the record 53, is characterized by low frequency and high amplitude ground roll event, C. And also, we can note at about 550 millisecond, an event D here, where reverse move out suggests an up deep reflector in this location. Here is we can see the 3 shot getter representative of the seismic data set along line 2. The signal to noise ratio for all records along the line 2 is less than that for the line 1 generally. A strong airway event E is evident in all records. You can see that. And event F here in the record 3 show a clear reversed move out that suggests the presence of the up deep reflector at the beginning of the line up to the record 11 really, whereas the record 72 on the right that represents the record at the end of the line 2 show clearly the fact that we have G here in the upper side of the section that indicating the presence of a refractor at the shallow part in the shallow depth of the section. In the left side of this slide, we can see the common midpoint supergator derived from three adjacent common midpoint gators along the line 1. In the central part, the corresponding semblance analysis showing the estimated velocity function. And in the right part, the interval velocity determined by the Dix equation. Stacking velocity were based on an integrated evaluation of constant velocity gathers, constant velocity stacks, semblance analysis. As shown by clear reflection here, and the relative sharp peaks in the semblance plot, resolution stacking velocity was quite good for event above 500 millisecond travel time, while velocity resolution was poor between 516 600 millisecond, and low in the below this time. Pre-stack processing was completed with application static correction, and because topography was flat, only residual static correction were calculated and applied to the data. Seismic data results are here summarized to allow a holistic portrait of the all-integrated approach. No velocity information from boreals was available within the area, the investigated area. Therefore, no time-to-depth conversion was made based on interval velocity derived from the seismic data. This velocity range from 1,700 meters per second in the uppermost part of the section, up to 3,600 meters per second in the deepest part. Two strong reflection here and here dominate the deepest part of the section, and the continuity of these events is interrupted by discontinuities interpreted as a deep fault with vertical displacement that can reach 100 meters. The interpreted units B and C are only supposed on the basis of geometrical feature on the reflector and on the basis of the seismic velocity. Whereas the upper part of the section is dominated by horizontal reflector interpreted as boundaries in quaternary alluvium deposit, the unit A. But despite the quality of the section, seismic data don't allow us to a stratigraphic distinction within the quaternary deposit. The time domain electromagnetic method is a geophysical technique that investigates the subsurface electrical conductivity by transmitting a controlled pulsed electromagnetic field and measuring the transient response of induced eddy currents in the ground. The application of TDM method has been widely used for describing the depth and the thickness of coastal aquifer, defining their physical and chemical properties, and assessing the marine intrusion and pollution levels. The surveys were carried out along the seismic profiles, the same line, using two different equipment in order to provide a better vertical resolution for the different purposes and a very high accuracy in interpretation. The TDM service, in the TDM service, the voltage decay curve represents the recorded transient response of the receiver. After that, the transmitted electromagnetic field is abruptly turned off. It describes the time-dependent induced voltage caused by eddy current diffusing into the subsurface, providing initial information on conductivity, variation, and with depth. The apparent resistivity curve here is derived from this measured transient response and express the equivalent homogeneous resistivity of the subsurface as a function of the investigation time or depth. Obviously, it serves as only a first-order interpretation before applying more advanced inversion techniques that allowed us to obtain the 1D layered inverse model. In the right side, we can see A series of 1D resistivity models obtained from TDM soundings, especially linked along the profile, to build an electrostatic section by correlating the resistivity layer across neighboring 1D models. The section highlights lateral and vertical variation in subsurface conductivity, allowing the identification of electrostatic units such as aquifer, clay layers, or saline intrusions. This is the TDM system used for the measurements. Is the system developed by Zong Engineering Research Organization, includes the controller transmitter that generates pulse the electromagnetic field, the receiver coil to record the transient voltage response, and data acquisition unit for measurements. And this is the scan that you can use for a TDM survey using the Zong system, consisting of a transmitting loop, the red one, that emits a pulse electromagnetic field, and receiver coil positioned to record the transient response. This is the second instrument used for measurement is the STEMFAST 48, and is intended to shallow depth electromagnetic sounding. The system provides effective work in any condition, including industrial city, placed with limited access for installation of standing antenna or loop, and provide acquisition of experimental data on the electrical properties of the reservoir. In total, 15 TDM soundings were acquired in our investigated area. The experimental data have been collected using 5 different frequencies, 16, 4, 2, 1, and 0.5 Hz, and using 6 different windows. The transmit current intensity has been set to 11 ampere. Late time resistivity after integration and normalization have been used to interpret by means of monodimensional models using the Zong TAM 1D software. The inversion were constrained by incorporating a priori information from the boundaries identified by the seismic section. This approach not only reduced the BSP error from 8 to about 4%, but also improved the lateral continuity of the 2D geoelectrical section, allowing us to improve geological interpretation. The TAM and TAM-FAST soundings has been used to construct the 2D section. This is the section of line 1 that show very conductive layer in the shallow part of the sections here, obviously due to the presence of salt, brackish, or fresh water in the sand deposit. In the central part of the section here, lateral resistivity changes are visible, whereas high resistivity layer in the red one are below 250 meters. Also, in this resistivity layer, here is possible to see lateral variation resistivity, probably due in correspondence of a fault change in the Paleozoic rocks. The TDM soundings clearly show the connection between the channels and distinguish different aquifers in the Paleozoic deposit. Here an overlapping of the TDM section onto the reflection seismic section that show a very correlation of the reflector with the electrostatic layers. In conclusion, the integration seismic and TDM data provides a comprehensive subsurface characterization of the Primavera Plain. The seismic profiles reveal well-defined stratigraphic boundaries and lateral variation in subsurface layers, consistent with the previously reported geological interpretations. The presence of discontinuities and velocity contrast suggests a compressed evolutionary history with alluvial and colluvial deposits overlaying the Paleozoic basement. The TDM data when overlaid on the seismic section, confirm the interpreted hydrological variation, provide additional constraint on the distribution of conductive layers. And the resistivity profile highlights zones of increased conductivity that can be correlated with alluvial sediments, while more resistive units correspond obviously to consolidated formations such as the metamorphic rocks. A significant aspect of this study is the use of seismic constraints to define the interaction of TDM data. The integration of seismic and TDM data so provide improve the confidence in identifying aquifer bearing units. So thanks for your attention.
Thank you, Patrizia. There are questions? No? Okay. Patrizia, the next presentation is the title. Can you?
Okay, you see?
Yes.
Okay.
But okay. Okay, the title is Outside and Inside the Surface, a statue of Apollo from Villa Corsini in Castello, Florence. The author are Capizzi, Di Santi, Adornato, Pingue, Carolo, Martorana, and the speaker is Patrizia Capizzi. Please.
Okay, good afternoon again. The title is, I'm talking to you about the case of the statue of Apollo. This is located in Villa Corsini in Castello near Florence. It's a marble statue represented the god Apollo as an archer from the collection of the National Archaeological Museum, Florence. And is the object of this talk, and it has been investigated within the project Bioscult, carried out by the Scuola Normale Superiore of Pisa in partnership with the museum. The purpose of the project is retracing the history, or rather the biography, of a selection of pieces belonging to the museum collection, housed at the Villa Corsini in Castello near Florence. The statue is a larger-than-life size. Is composed of a head derived from the 4th century before Christ prototype, joined to a body inspired by models from the beginning of the 5th century before Christ. It will be then important to define whether this pastiche is a Roman or a modern work. Having no information about the provenance of this unique sculpture, this research shed new light on his biography through the investigation of the material. Specifically, 3D ultrasonic tomography is employed to examine marble characteristics. In order to trace out the life stages of the statue of Apollo, the present contribution is structured in two sections. The first one is devoted to an essential historical artistic study of the sculpture, while the second part we show the results of the 3D ultrasonic tomography conducted on the marble of the statue. As we can read in the most recent guide of the collection housed at Villa Corsini, the head of is almost certainly original because, besides being compatible with the rest of the figure in terms of its size and type of marble, it reveals an irregular fracture line at the base of the neck that coincides perfectly with the one on the bust. But however, in our opinion, the hypothesis that the head belonged to this statue from its origin is not yet totally convincing, because for the following feature. The head bears evident trace of polychromy, while the body does not preserve any trace of color. After one of the last restoration of that sculpture made all the original fracture were no longer visible, it's particularly interesting to note that the fracture in the neck is very clearly recognizable in some historical pictures in the museum. It is noteworthy that observing the original fracture, the head is slightly tilted towards the left. Even for today, we gain a different perception of it. After this initial observation, we can now take a look at the body of the statue. It represents a walking naked male figure. His arms are bent at the elbow and his forearms are stretched forward in a gesture interpreted as that of an archer ready to shoot an arrow. The torso, stiffly upright and the frontal, don't follow the movement of the arms and is also look independent from the legs. A short cloth fastened on the right shoulder covers part of his chest, and it drags in a somewhat unnatural way around the shoulder and the upper part of the left arm, and then it goes backwards here, moved by the archery impetus. Maybe. A strap is above the cloth and is visible both on the chest and on the back. So we would expect to see the quiver on the archer's back, but there isn't a quiver at all, even if its volume seems to be suggested by a mass of folds. It should be noted that the Apollo statue has been wrongly positioned in his last arrangement at Villa Corsini. It's clear, in fact, that the left foot here is incorrectly raised, altering the original posture of the whole statue. Thanks to the 3D model, we can finally position the statue correctly and discover that the head is actually turned to the left. Apollo, therefore, is turning its gaze in a different direction from the one suggested by the body, and also by the lost arch. In other words, the head is divergent from the torso. At this point, what we can say about the chronology of the statue? Unfortunately, we have to admit that the dating of the body is very challenging. Also because of his restoration, which made the marble surface conspicuously flat and smooth. Because of this, there are no reliable diagnostic elements indicating an almost certain chronology. However, in our view, some frontal inconsistencies, such as the strap without the quiver and the unnatural way in which the cloth drags around the upper part of the left arm, could make the ancient origin of the body questionable. Regarding the head, its chronology is simpler to define. Unlike the body, the drill marks of the rendering of the hair point to the middle of the 2nd century. The combination of different models in one sculpture is not for the Roman age, but the 3D model actually reveals the presence of an interesting lacuna on the top of the ear, on the top left side of the head, that could be could be the print of the hand originally put on the top of the head. In this case, we should think that the head was originally created for a different type of statue, depicting Apollo with the hand resting on the top of the head, according to the Luceios scheme. And that only in the later phase of his life, it was placed on the body of an archer Apollo. For the investigation, I used the ultrasound tomography investigation that allowed us to highlight the area inside the material with characterized by low velocity value. The tomographic inversion was performed using the simultaneous iterative reconstruction techniques proposed by Dines Lightly in 1979. And the first question that we have to solve is what number of shells we have to use for our invention. The data set acquired with closely specific points where the arrivals should be undistinguishable according to the Fresnel zone theory, provide more reliable results. And we see that the models with the pixel, in our case, with the box size smaller than the limit predicted by Fresnel theory, can provide better results than expected, as long as the dataset is sufficiently dense. Another question is if for the inversion process we have to use the straight or curved array. The faster anomaly attracts the energy, and the slow anomaly rejects the energy. But this behavior is not taken into account if we use the straight array. So we decided to model and to use the curved that are really the refracted ray paths. And our model, inversion model. However, we believe that the use of curved beams sometimes is too strong simplification through distribution of the array inside the volume. Overall, in the case of the statue, that is a very regular model. On the left side, you can see the 3D model of the statue, the Apollo statue, and the location of the measurement point used for the measurement of the ultrasound velocity, time and after velocity, used the 400 measurement points, and that allowed us to use a model with starting child dimension for inversion of 5 centimeters. The instrument used for the experiment was the TDIS 16 produced by Bowyer that can able to use simultaneously 16 channels. The receiving and the transmitting probe have a central frequency of 55 kilohertz, and in our case for a good accomplishment for the probes in the surface of the stage, we equipped the probes with the special cone-shaped aluminum support. And the stage was covered by a transparent pellicola. Here we can see the results of the velocity model of the stage. And obviously, it's possible to cut the model in any direction. The data convection was performed using the Jotom 3D software and the 3D rendering using the Voxler software. In the blue area, we can see the velocity area characterized by low velocity that corresponds at the material with different characteristics. Obviously, compact than the marble, the statues. We decided to isolate this area, and we see that probably this area are correlated to the presence of the plaster used in the plaster restoration that probably cover possible fracture and the injuries of the statue. Here we can see in particular zoom in the right arm and the correlation with the plaster that was camouflaged by the picture and restored. And here the probably reconstructed of the fracture in the body. Also, we decided to highlight the high velocity area inside the marble, the very high velocity area. And the problem is these are linked due to the presence of metal pins for the relocation of the fractured part. In fact, metal allow the ultrasound to propagate very quickly. Of interest is the shape that we can see between the head and the neck that seems to correspond of two different pins. It would confirm the hypothesis that the head was added to the body at the latter stage, most likely that in the modern era. In conclusion, the fracture on the base of the neck, now hidden because of the more recent restoration of the statue, non perfectly correspond with the one of the torso, since a visible modern integration was inserted between these two parts. The current positioning of the statue, which is clearly incorrect, has altered our perception of the piece, and particularly disfigured the original pose of the head, which is actually turned to the left. The interpretation lacuna discovered on the top of the head is correct, and the head was centrally not created to be on this body, but on the statue depicting an Apollo vicarious with the hand resting on the head. The result of the 3D ultrasound tomography unresting revealed the probable presence of internal pins connecting part of the statue, and near the neck of the statue, two metal pins are probably evident, which could confirm the hypothesis that the head was added to the body in the modern times. Some low velocity area in blue were also identified that seem to be linked to the presence of cluster addiction, which were camouflaged with painting techniques. And therefore, the statue we see today on its last phase of life could very likely be a modern pastiche composed by an ancient head of Apollo and a body that is very difficult to date, up to the possibility that it could have been made by modern sculpture, should be not excluded. So thanks for your attention again.
Thank you, Patrizia. There are questions? No? Okay. So we are finished, and thank you for all the speakers and for the present in the session. And now the coffee break.
Bye.
Thank you. Bye.
Bye. Bye.
Grazie Sara. Queste altre sessioni
Devo dire che siamo stati fortunati per il computer, perché tutti hanno detto che internet così a me c'è qua tutto bella esterno, meno male. Sì, prego.
da dentro l'università.
Patrizia, scusami, stai ancora condividendo lo schermo? Perché ti lo scrivendo anche io.
Perché lo metto sempre in posti diversi? Ma come non quei colpi assurdi?
Non ci sentirà mai.
Sì, i bridge.
Sì.
Io sono la consulente dell'agenzia di Brescia, l'università di Brescia. Mi ho visto e detto no, sembra un po' surreale.
Ma per un invito.
No.
Ma per un invito.
No, per il programma di bacino.
Ah, proprio la tocca adesso.
E non possiamo. Cioè, anche perché rischiamo che vediamo le sue robe.
Sì, abbiamo presentato ieri mattina.
Perché non
Abbiamo un progetto di
communicazione.
ricerca per comunicazione, essendo in cui si dentro il gruppo di Lupe,
Ok.
il progetto che
Ok, non sta più condividendo.
che
So good afternoon, everybody. Good afternoon, Angela. Good afternoon, Gloria. I think we should wait someone from... Ciao, Angela. We can wait someone from Cagliari and also from Melba, and then we can start. Few minutes.
Okay. Puoi farla anche tutta in italiano, non c'è nessuno. Serena.
Ciao a tutte.
Ciao, ciao Serena.
Ciao.
Faccio una cosa avanzata così ti saluto anch'io.
Possiamo anche fare.
Ciao a tutti.
Ciao.
Ciao Gloria, anche non so se mi sente.
Ciao.
Ciao Angela. Siete buone.
Vediamo se Gloria ci sei. Gloria and Melba, buonasera, good evening.
Siamo sabato.
Ciao Melba. Gloria, sai se è collegata? Cioè c'è,
Sì.
però sai se ci sente?
Che ci sente non lo so, però dovrebbe esserci, mi aveva detto che si sarebbe collegata a breve, a momenti, quindi dovrebbe essere là.
Ciao Melba.
Ciao a tutti.
Rifaccio comparsata.
Complimenti per ieri, ho visto la presentazione, molto bella.
Ma quale presentazione?
Quella sul PRIN.
La mia?
Sì.
Ah, non avevo visto che eri collegata.
No, perché ho seguito la diretta su YouTube.
Ho capito.
Sì, no, così, è una esterna.
Just a check, Gloria, can you hear us?
Un secondo, la chiamo.
Sì. No, perché senza in giugno.
Marianna, vedo anche, buonasera Marianna, che bello vederci tutti.
Buonasera Silvia, è un piacere.
Io meno 22, ho usato un po' troppo Max.
Vediamo se riusciamo a partire.
Anche adesso non è il biglietto dell'altro.
No.
Il posto. Sì.
Prof, giusto un minuto perché Gloria ha avuto un problema tecnico con il microfono, ma si sta collegando da un altro browser.
Ok, va bene. Magari, siccome abbiamo un po' uno schedule molto serrato qua, magari intanto comincio a introdurre la sessione e magari cominciamo con la presentazione di Melba, poi così Gloria ha tempo di risolvere i problemi tecnici. Quando poi si collega facciamo la presentazione di Gloria. Cosa dite? Così
A me non cambia nulla, come volete, quindi ci sono.
Okay, so maybe we can start. So good afternoon, good evening, everybody. Greetings from Istanbul. Okay.
Hi, everybody. Can you hear me?
Yes, now yes, Gloria, we can hear you. So you can start. Great. So let me introduce this afternoon session. It's a session we proposed with some colleagues. Many of them are actually online, related to a national project we are carrying out in Italy with the University of Ennacore and the University of Cagliari, and of course University of Parma. That's me with my colleagues from Parma University. And the topic of today's session is street experiments. So the title steps stays from street experiment, from street experiments to planned solution. We have a very tight schedule this afternoon, so please try to have a presentation that lasts maximum 15 minutes, better if you can stay into 12. So we can start with the first presentation. Maybe I can just briefly introduce the first two presentations because I am co-author of both of them. The first one, presented by Gloria Pellicelli, focuses on planning guidelines for parklets installation and was developed within the Ecosister project we are actually also carrying out in Parma. While the presentation of Melba Cedro, I apologize with the colleagues because I don't know why, but in the program of the session, not all the authors are listed. I asked to change, but it was too late, so I apologize for that. Anyway, Melba, maybe you can start by presenting all the authors when you will start your presentation. So Gloria, the floor is yours. Gloria Pellicelli, University of Parma, will present a paper titled Planning Guidelines for Parklet Installation, a Possible Integration into Urban Planning Strategies.
Can you see my screen?
Yes, we can.
Oh, thank you. Thank you, Professor Rossetti, for the presentation. Today we will see some research goals, the framework of the research, the methodology adopted for this study, and the application to a case study, the planning guidelines, and finally some conclusions. This paper is based on my study presented in the paper last year, which defined a cognitive framework to specify criteria for identify priority intervention areas through a protocol applied to the Oltretorrente neighborhood in the city of Parma in Italy. And the current research revisits the case study of the same neighborhood and aims at defining planning guidelines for installing parklet within neighborhoods in the medium-sized cities. This approach would make it easier for association citizens and potentially the administration to choose the best location for the intervention. On the topic we are addressing, that of mobility, we see how Italy is the first country today in Europe in terms of cars per 1,000 inhabitants, and Eurostat and Istat tell us that the trend is increasing. We ask ourselves how to plan parklets for maximum positive impact, how interventions can lead to an improvement in the city and not only in the place where parklets can be located, and what else needs to be planned, and what changes need to be made all around the intervention to make it effective. First of all,
A literature analysis was carried out in this study. This was approached through a SWOT analysis, which is useful to understand which are the driving factors and which give push to these interventions and which are the difficulties that may be faced. Among the strengths, we see the fact that they are functional, low cost, and focus on certain needs, on people needs. Among the weaknesses, there are the lack of resources, the lack of a common vision, and the difficulty of the approval process. Among the opportunities, they create, we can say, the reduction of parking or parking spaces, and the fact that they allow socialization. And among the barriers, there are low frequency in time when these interventions are made, and the fact that they are often the site of unsuitable social behavior. This research was divided into some steps. The search for literature and project to highlight where it is the most suitable location for the intervention, the creation of a protocol to bring out the most suitable roads, the application to a case study at a neighborhood level to demonstrate how the protocol works. And at this scale, have been also conducted some interviews with actors directly involved in the realization of 2 parklets within the case studies area. And all these led to the creation of planning guidelines which summarize the knowledge acquired. They include what is the object of the research, who are the promoters, when and where it should be located, what urban needs it meets, and how it is approved. As I said, the methodology includes a qualitative approach, specifically semi-structured interview, conducted with the key stakeholders involved in 2 significant interventions. This phase is related to the case study and aimed at verifying and evaluating the implementation of parklet completed last year. The questions aimed at understanding how the interventions were implemented, what difficulties have been faced, and how the neighborhood residents experienced the project. The promoters of the parklet in Parma were the scholastic group professor Vernazza, who designed the interventions, and engineer Fulvi, who worked with them as a professional. The main results we can highlight are that the implementation process was particularly long, and the most difficult aspect was the fundraising. Also, the private contribution of the creators in terms of materials and funds was significant, and another main focus is on persuasive strategies for the dissemination to convince people and the administration that they are helpful. Here we can see the results of the protocol location, which was the subject of the previous study within the Oltretorrente district in Parma, which is a central neighborhood of the city, particularly characterized by vehicular traffic. And the results on the maps show the best location for social parklet, pocket parks, streeteries, school parklets, and bicycle parklets. Moving on to the guidelines, let's start by saying what is the object of the study. Parklets, as mentioned, are interventions that fall under the category of street experiments. And their aim is to transform parking spaces used for vehicular traffic to spaces that promote active movement and socialization of people. Not directly, as they do not exclude vehicular traffic flow, but indirectly because they create social spaces. This is through the conversion of parking spaces into public ones, and they consist of a platform, usually made of wood, that expands the surface of the footpath. About the promoters, they can be the commercial traders for attracting people to enter the store or promote the consumer comfort, association to improve the quality of life of the citizen, educational institution to promote student safety and sociability, and administration to share the vision and the needs of different stakeholders and citizens. It's appropriate to realize a parklet when these characteristics are present at the same time. They are the characteristics of the street, such as the absence of seats, high accident rate, characteristics of the place, such as the presence of school and commercial activities, and the need for context management. All this is reflected in the choice of location for the installation of a parklet, which considers everything we have said. Starting with the street where there are the parklet, which is the main element, we consider the presence of feature concerning the street, attractive areas, mobility services, and qualitative aspects of the context, such as the presence of lighting, lack of seatings, etc., bike racks, etc. Why do we want to create a parklet? To create vibrant, safe, sustainable, and healthy cities which have spaces for people, attractive services, safe spaces, and which encourage active mobility. The how a parklet is approved is the result of interviews with the two promoters previously mentioned. So how does all this happen? The developer group has the first idea and applies to the municipal administration for permission and obtains approval to use a car park space for usually some limited period of months. The first parklet built in Parma then obtained approval to be permanent through a petition. The architectural design of a parklet is then developed, and in the meantime, the developer group works on recruiting stakeholders to obtain materials and funds. And finally, it is built, in this case by the students, but usually by the citizens. It should be highlighted that the biggest challenge is the management and maintenance due to acts of vandalism and unsuitable behavior, as I said before. This research, of course, does not mean that the installation of a parklet solves all the problems we analyzed earlier, but the realization can be a starting point to create social poles and in this way create a cycle pedestrian flow in today's particularly critical streets, such as in the case in Parma, and reduce vehicular traffic, which is not only for transit but also for parking, and so it creates traffic congestion, discomfort, etc. The present this research enriches our previous work, trying to answer some questions left behind. First of all, it's enriched through the interviews. The protocol also considers cultural buildings, but also other points for promoting sociability, such as school or neighborhood primary services. And also we calculated the parking spaces lost due to installation of parklets. They are more than 300, so the relocation is unrealistic, but we thought that in future maybe we can think about it, because maybe it's not necessary if the ultimate goal is to promote slow mobility instead of vehicular traffic, no? Future developments include the interviews with citizens and administration, surely, and a survey to know their opinions, and working on the simplification of approval process. Next step is of this research include the attempt of answering the following question: how to integrate these guidelines with the existing urban plans to turn these interventions into planned and permanent practices in our city,
and if this intervention can contribute to climate change adaptation, for example, through desealing operation. Thank you for your attention.
Thank you very much, Gloria. Okay, what I can suggest you, if there are very, very specific questions to the presentation, we can have it now. Otherwise, maybe we can leave a little bit of time for a discussion at the end. Okay? Okay, so
yeah,
no
sure.
Okay. Questions? No? Okay. So we can move to the second presentation. So Melba Cedro will present a paper, How to Ensure Safety and Promote the Permanence of School Streets, co-authored by also me, Vincenza Torrisi. So you can start sharing, and also Gloria Pellicelli, I think. Yes, okay.
Okay. Can you see my presentation?
Yes, we can.
Okay. Okay, thank you, Professor, for the presentation. Good morning, everyone. I am Melba Cedro, and I am a PhD student at the University of Parma. Today, I would like to introduce our research project entitled How to Ensure Safety and Promote the Permanence of School Street. The concepts that we will discuss in this presentation are the research objectives, the history of School Street, so in this case, the introduction, the methodology we used, the applications, and the case study. As you can see in this slide, speaking on the objectives, the main one were three. So the first one is to conduct a comparative survey to define guidelines for the management of school street in medium-sized Italian cities. The second one is to conduct an assessment and simulation of the effects of post-intervention vehicular traffic congestion and application on the case study. And the last one is finally lead an analysis of pedestrian vehicular flow for the study of behavioral variables. Okay, starting from the introduction, as we know, the concept of tactical urbanism is a powerful approach for creating a meaningful long-term action in our city through short-term and low-cost actions. And this phenomenon focuses on reimaging and transforming urban spaces, often by temporary changing street use or just regulation or design. And this intervention, which we call street experiment, help us move away from street just designed for traffic and towards environments that are vibrant and people-centered. So across Europe and beyond, we see inspiring examples such as pop-up bike lanes, play street, or just colorful plazas that demonstrate how simple intervention can make our street safer, more inclusive, and more enjoyable for us. So starting from this consideration, one of the most important street experiment intervention is the school street. The first Italian school street were planning years ago, and the first cases are represented by the city of Bolzano and then the city of Milan. And today, according with the new Italian rule code, we can define a school zone like as an urban area near educational buildings where special protection for pedestrians and environments is guaranteed. So, school streets are characterized by their temporary nature and the low cost, which makes them accessible and adaptable to many cities. They are designed primarily with children's safety in mind, but their benefits expand to all communities, to the entire community. And success depends on strong partnership between local authorities, parents, and municipalities, demonstrating the power of collaboration in urban transformation. And finally, we can say that school street promotes active mobility. So the structure of our work is as follows. So the first phase is a comprehensive literature review, which allowed us to identify international experiences and classify key variables influencing the development of progressive solutions for managing vehicular and pedestrian flow. And this step is essential for us for understanding what factors might help or hinder the transition from temporary to permanent school street. Building on this foundation, We identify the tools and analysis needed to classify factors that support various traffic management scenarios. And then we conducted a study of the area using a thematics map to analyze physical elements and conducting field surveys to measure vehicular and pedestrian flow. And this workflow, as you can see in this slide, ensures a structured approach from theoretical framework to practical data-driven analysis. As we know, the location and characteristics of school street are closely linked to sociability and road safety. So the phenomenon of school street has expanded rapidly, especially during and after the pandemic period. And different countries have approached the management of road safety for vulnerable users in various ways. In fact, some have adopted open street, so creating multifunctional spaces, while others have focused specifically on school street, emphasizing collaboration between local authorities and building educational solutions. So our comparative analysis based on literature and local guidelines categorize intervention by scope, typology, and level of action. And this helps us identify common factors that can serve as a framework for analyze modal shift and the success of this intervention. In this case, a notable example is London, which has been particularly successful in implementing and sustaining school street. So we can identify several key variables. The first one is the figure of promoters, so local authorities, school communities, and government initiatives. So then users, so the children, parents, and school staff. Then negative externalities before the intervention, so traffic congestion, air pollution, accident, and low physical activity. Then benefits after the intervention, such as safer environments, improved social interaction, training for cyclists and pedestrians, reduced car use, and of course, lower pollution. Then we have no transit ban and exceptions, so that's represent who is provided allowed during the closure of the street. And finally, time. Let's represent the duration and timing of the closure street. And we can identify key variables, but also a permanent process. So the process of making school permanent involves several key steps, as you can see in this scheme. So the first step is location and use. So it's important to analyze factors influencing the choice of location, such as street topology, traffic level, air quality, and predominant uses. And engaged with the school community is essential, as this area serves vulnerable users and can support extracurricular activities. Then we have stakeholders, step 2, stakeholders identification, so identify all relevant stakeholders, including local transport authorities and school communities. Then step 3 is installation and management, so implement appropriate signage and barriers and ensure that there are staff to manage the closures and enforce rules. Then monitoring, so in this case, maintain intervention, collect user feedback, and assess efficiency and replicability. And the last one is guidelines, of course, best practices, so develop toolkits and care documentation to educate citizens and promote participation. And each step, in this case, is designed to ensure that school streets are not just temporary experiment, but become a lasting future of the urban landscape. So to assess the impact of school street intervention, we conducted a detailed traffic and pedestrian flow service in the study area. We use optical cones at key focal points to ensure accurate data collection. In fact, as we can see in this slide, the first table on the left present the vehicular flow survey scheme detailing the typology of vehicles observed, while the second table present the pedestrian flow survey scheme. And these surveys allowed us to quantify the changes in traffic patterns and pedestrian activity resulting from street closure. Okay. And then using JS software, we analyze the geometric and functional characteristics of the study area, focusing on both road and pedestrian spaces. So as you can see, the table 3 details the characteristic of cycle pedestrian paths. Table 4 summarizes the future of pedestrian paths, and Table 5 describes road space, including traffic control device to help us understand how the physical environments support the active mobility. So our methodology was applied to the Oltrarente neighborhood in Parma. This district is located west of the Parma River, a part of the city center. It's bordered by Urban Boulevard, and it is divided into many parts. The northern part is dedicated to public facilities like Parco Ducale, that represents one of the most important urban parks in the city, while the second part is mainly residential. The area is vibrant and multicultural with significant commercial activity along Strada Massimo d'Azeglio, Strada Nino Bixio, and there is a concentration of secondary schools and university buildings. So as you can see, the first figure left provides an overview of the neighborhood, highlighting the key facilities, while the second one maps all pedestrian and the crossings in the areas. And these maps illustrate about the opportunities and constraints for implementing school street in this context. Focusing on Viale Maria Luigia, one of the main school street in Oltrarente, we analyzed the current interventions and their effects. The street is strategically located near several schools and serves as a primary access route for parents and students. And the intervention here are still temporary, but our goal was to test the methodology to support the transition to permanence and integration into broader urban planning strategies. In particular, the survey was conducted during the closure and the opening of the street, and we focused on 3 main southern traffic nodes, and they are Via della Salute, Piazzale Rondani, and Ponte Tala Roundabout, as you can see in this photo. In this case, the goals were to evaluate positive and negative externalities and provide that data for the simulation model and analysis based on these findings from the geometrical and functional analysis. Result. During the street closure, we observed several critical uses affecting safety and the traffic flow. Firstly, in terms of cyclists and pedestrian behavior, there was a frequent diagonal crossings by bus group, often disregarding the design paths. Cyclists were also forced to use the carriageway because student groups were blocking cycle routes, creating potentially potentially dangerous situation. Another concern was the inconsistent reopening of the street, which introduced an unpredictable element and increased the risk for all users. Then around the Ponte Tale roundabout, we noted a significant congestion. Crossing, they were particularly unsafe due to poor visibility and then for longer pedestrian crossing times. Regarding the parklets, their usage was minimal during the closure period, but that is a really interesting point because they saw more users added it, highlighting a possible mismatch between provision and actual demand. And then several unauthorized vehicles were able to enter during the closed zone, the closure of the street, largely because traffic officers were not systematically managing access. And lastly, parental vehicles contribute to high volume of traffic during the closure. However, there was a sharp drop over 15% after the opening of the street, indicating that many cars are linked to the school drop-off. So, as a part of our work and special analysis, as I said, we examined the geometrical and functional characteristics. So, first, starting from the east side, we recorded a dedicated cycle pedestrian path. The cycle lane is 2.50 meters, which is appropriate. However, the pedestrian path is frequently bootstrapped and lacks continuity with optimized safe working conditions. Instead, the west side presents a wider pedestrian path, but just 3 meters are effectively used due to fixed obstacles. And this side is really active because present 13 access points, in which of which 6 residential and 7 related to school activities. Looking at the street as a whole, consists of a single one-way carriageway running from Ponte Italia to Piazza dei Rondani. We identify 5 pedestrian crossings, all at the street level, contributing to pedestrian accessibility. And as for traffic calming devices, the street includes 1 roundabout, 1 raised crossings, which are important feature, of course, for moderating vehicle speed. And these findings provide us a detailed understanding of how special design and infrastructure function in practice, and where adjustment could enhance the effectiveness and the safety of the school street intervention. So, based on these findings, we are feeling that the school street improves internal safety and promotes active mobility. However, several critical issues have emerged that require consideration. First of all, the roundabout is a critical point and needs either a reconsideration or a complementary regulation. Furthermore, student presence is significant affect the usability of the infrastructure, particularly for cyclists, creating a potential conflict in usage. In addition, there is a lack of supporting measures, because of traffic redistribution strategies or an effective parking plan, which are essential to ensure the success of this initiative. And equally important, the intervention creates negative externalities in the surrounding areas, potentially shifting the problem rather than solving it. So, to conclude our research demonstrates that school street can be a powerful tool for improving safety, quality, and the overall urban experience around school. However, the long-term success and permanence depends on several interconnected factors, and these factors are our recommendations. So, the first one is a holistic and multi-level approach, so integrating between local authorities and local communities and the urban planners. The second one is institutional support and stable funding. So in this sense, municipalities should allocate dedicated researchers for the ongoing management, maintenance, and adaptation of school street. And then we have community engagement. So active participation of parents, students, and school staff is essential. Then continuous monitoring and evaluation. So implementing a systematic data collection using both quantitative and qualitative methods. Then equity inclusivity. In this sense, policymakers must ensure that school streets are accessible to all, including families with special mobility needs and or those living far away. Then flexibility and adaptability, and the last one is the snap and knowledge sharing. So documenting best practices and lessons learned and sharing them with other cities or communities can accelerate the spread of school street programs. So, as a last consideration, we can say that school streets are more than traffic intervention. They are a chance to reshape a relationship between school, communities, and public space. The proposed methodology, in fact, has proven effective at the neighborhood scale and its replicability in medium-sized cities. And microsimulation, in this sense, could support the future research, helping simulate flows, assess long-term impacts, and better understand pedestrian behavior and infrastructure performance. Thank you for your attention.
Thank you very much, Melba, for the very interesting presentation. Quick comments or questions? Okay, so we can move to the next presentation and maybe leave a little bit of time for the discussion at the end. So thank you very much again, Melba. We can move now to the next presentation with from the colleagues of the University of Cagliari, so Chiara Garau, Andrea Manca, Maria Serena Pirisino, and Francesco Pinna. I think that Maria Serena, will present a paper on a new definition of a smart and healthy city. Please, Serena, go ahead.
Yes. Okay. Can you see the presentation?
Yes, we can.
Okay, so okay. I have a problem with okay. Okay, good afternoon, everyone. And oh, sorry. Oh. So, just a moment, please. So I change the desktop.
Okay, actually, we can see your screen. It's not, let's say, presentation mode.
Okay.
But if you enlarge it a lot, I think we can.
Yeah, it's okay. Okay.
Okay. Yes, it's fine. It's fine. We can see.
Okay, so good afternoon, everyone. Today I will present our research entitled A New Definition of Smart and Healthy City through a Literature Review on Accessible Urban Green Spaces. As is known, the World Health Organization defines the urban green space as an important part of public open spaces and common service provided by a city and can serve as a health promoting setting for all members of the urban community. Its many benefits in the urban environments and its beneficial impacts of the health of citizens have been object in several research conducted over the last 3 decades. These studies support the belief that urban green spaces should be equitable, accessible, and inclusive for all residents, and the urban planning should prioritize this goal. Thus, an increasing number of cities are implementing measures to enhance the quantity, the quality, and the accessibility of the green area. And from this consideration, automatically lead to the following unresolved issues that are our research questions. The first is about the definition, yes, of the accessible urban green spaces. Which parameter and peculiarities come into play in the various scales. For example, in the urban scale, the diffusion and distribution within the city, or in architectural scale, the compliance with the requirements of the universal design principles. The second, for another point of view, such as the environmental justice and the social equity point of view, what aspects need to be analyzed? For the second questions, what are the methodologies and the technologies most successful used in the investigation and the evaluation of the urban green spaces? The third questions is about the planning and the administration process, and the
involvement of the resident and the general users in this process. That this environment is essential for improve the quality and the efficacy of the project. And finally, the fourth questions is about the relationship between the urban green spaces and our lifestyle, and the relationship between the urban green spaces and the vulnerable context such as historical cities or degraded surroundings. Starting from these questions, the paper aims to provide an advanced framework for the accessibility and inclusiveness of urban green spaces from a systematic and critical literature assessment. Specifically, the study investigates the potential of urban green spaces, their accessibility, focusing to establish an operative framework that defines scientific parameters and offers critical insight into planned and design solutions for evaluating the urban environments in smart, air, and inclusive cities. Following the prevailing approaches and methodologies, the literature review is conducted in 5 steps: problem formulation, data collection, data evaluation, analysis and interpretation, and public presentation. A systematic evaluation of the literature through the Scopus database has identified 125 contributions in English, categorized as articles, book chapters, books, conference papers, and reviews. The chronological range is from 2015 and the first part of the 2025. These figures illustrates temporal growth in publication concerning these topics, rising from 1 and 6% of between the 2015 to the 27% in 2022. The contribution reveal for overreaching themes, which are further elaborated and summarized here. Spatial equity and environment justice, analyze and assessment of the process of defining accessible green spaces, planning and management of urban green spaces, connection, association, and relationship. Moreover, the figure in white following expose has the contribution are balanced in the different themes from chronological point of view. And is interesting to see in what that only the thematic in reference to planning and management has a more homogeneous distribution in the decade under consideration, while for the other issue, there has been for all a consistent significant increase in 2022. The geographical context under examination are distinct. Europe and Asia are the principal regions of study, with further examination of other locations, including Canada, the United States of America, Latin America, and Australia. And now I show the results about the thematic framework. So the first is spatial equity, environment justice, and social equity. Defining the accessibility of the urban green spaces is not easy. Due to the complexity of the aspects and the elements involved, such as the physical and dimensional aspects, and the environment justice, social and spatial equity issues. In the evaluative process of the accessibility, it is essential considering the different scale of intervention, equitably assessing the element and the issue at each level. At the same time, the spatial equity is to be observed on different types of urban green space, and their difference as well as spatial distribution characteristics and social economic state. However, a significant future not extensively investigates its part of the accessibility of the urban green spaces in the architectural scale and on the universal design scale. Another important thematic is concerning the analysis and the assessment process. The research put in evidence that the definition of accessibility, usually with reference to the green spaces, is quite extensive. And this concern both physical and dimensional aspects and the environmental justice and social equity issues. Thus, the analysis and the assessment process on accessible urban green spaces are numerous and diversified, depending on the aspect of the accessibility that is to be investigated. Specifically, geographic information system database approach is widely used, both as a unique method and in combination with other methods of analysis, such as spatial syntax, remote sensing, or statistical techniques. Several research have been demonstrated that this kind of analysis is a valuable tool for planning and decision making at both municipal and regional levels. A significant example is represented by the Barcelona Green Axis initiative. This project sought to convert 1/3 of the streets inside its 19th century expansion drive into green spaces, so enhancing safety and comfort for pedestrians, cyclists, and other social activities in urban environments. This basic analysis gives a comprehensive framework of the transformation of the way to connect green infrastructure system and significantly increase accessibility to green area. The third thematic is concern the urban green spaces planning and management. The research put in evidence that is important, is very important, these are primary goal for urban development, establish inclusive urban green areas. In urban green space planning design, many relevant future and aspects are considered, including the green, the connectivity, functionality, and accessibility. The complexity of this process should lead to the definition and an independent operational approach, a sort of a green infrastructure planning, where every local governance should have tools and methodology to implement appropriate urban green spaces, planning, and operative measures able to design and networking of green spaces and providing user opportunities and other functions, as well as accessibility to the whole community. The participatory methods are crucial for both users and potential users, such as marginalized group in the planning and the development of the public urban spaces, as well as the management. In conclusion, the fourth thematic is about connection, association, and relationship. The study investigated, we put in evidence how the green urban spaces are closely connected to our lifestyle aspects, such as social interaction, health and safety, and to our perception of the cities. And in this viewpoint, the accessibility of these spaces becomes essential. So the urban green spaces become multifunctional spaces and satisfy to the diversified interests connecting heterogeneous features such as child-friendly and user facilities for family, and designing vibrant spaces for socializing, high-purifying plants, and scenic pathways, all sustained by enhanced safety and accessibility, and ensure that green spaces continues to benefit citizens also during emergency conditions. In conclusion, this paper is part of ongoing research aimed to examine the potential of the urban green spaces, its accessibility, with the aims to establish operative process able to define a scientific definition, and to propose a critical reflection about the planned and design solution to transform and enhance the urban landscape in smarter, healthier, and inclusive cities. In conclusion, the research agenda aims to pose a critical reflection about the planned design solution, to analyze the best practice and to suggest strategies able to transform and enhance the urban landscape in smarter, healthier, inclusive, and more inclusive cities. Thank you for your attention.
Thank you very much, Maria Serena. Thank you very much, Serena. Okay, if there are no specific questions, we can move to the last presentations of today's session. So Tiziana Campisi, Giovanni Giuseppe Iacuzzo, Angela Ricciardiello and Marianna Ruggeri from the University of Ennacore will present a paper on CPSO for innovative transport planning and designing. So Angela, the floor is yours.
Thank you, Silvia.
I think
maybe
you must stop sharing. Or Angela, you can start sharing, and I think you can overlap.
Okay, right. Okay.
Screen. Perfect.
Can you see my screen?
Yes.
Okay. So thank you, Silvia, for the presentation. As you said, this is a joint work with Tiziana Campisi, Giovanni Iacuzzo, and Marianna Ruggeri from the University of Ennacore. And it has been developed within the research project Moving Step that has yet been introduced. After an introduction on mathematical models for the simulation of traffic flow, a new algorithm that combines neural network model and continuous particle swarm optimization technique will be presented, and then it will be adopted in order to predict the short-time traffic flow of a smart traffic control region. And at the end, the described procedure has been applied to a case study that is Boris Giuliano Street in Sicily. So, as already said, this work is one of the results within the research project Moving Step, and in particular with the work package dealing with the modeling and the optimization approach for the optimization of the scenarios. Generally speaking, the aim of this task is the definition of an optimal mathematical model describing both pedestrian and traffic flow dynamics, depending on the urban scenario assumptions. With research of the optimal space and design plan investigated by means of an optimization tool that is the continuous particle swarm optimization. Model for simulating traffic flows are generally tools for analyzing and predicting traffic effects, because they can be used, for example, in planning intervention on transport networks, such as the construction of new roads or the renovation of existing ones. Indeed, the increasing volume of urban traffic, especially in the last decades, put into evidence the challenges of road congestion and environmental impact. So the ability to accurately predict vehicle flow become essential for implementing effective management strategies, as well as for improving mobility quality. And so, with other words, an accurate prediction of urban traffic is an essential tool for optimizing the mobility, as well as for reducing pollutant emissions. As concern the mathematical model considered in this work, a deep neural network has been taken into account. A deep neural network is an artificial neural network with multiple hidden layers of units between the input and output layers. Deep neural network can model complex nonlinear associations, and so for this reason, they result particularly effective in fields such as image recognition or natural language processing, but also in the context of the traffic dynamic modeling. In fact, DNNs show their ability to detect both complex dependencies, both in terms of time and space, that usually characterize the traffic patterns. And among the enhanced, long short-term memory networks have the feature of retaining long-term dependencies in sequential data. And it allows to exhibit excellent performance in time series prediction tasks, such as traffic flow forecasting. LSTMs resemble standard recurrent neural networks, but here each ordinary recurrent node is replaced by a memory cell. A memory cell can be considered as a layer of neurons in traditional neural network, with each neuron having a hidden layer and the current state that here is denoted by HT and CT. On the left, you can appreciate the scheme of the LSTM architecture that involves the memory cell, which are controlled by 3 gates. The first one is the input gate that controls what information is added to the memory cell. It means that the input gate is used to quantify the importance of the new information carried by the input. The second gate is the forget gate that determines what information is removed from the memory cell. It means that this step is necessary to decide whether we should keep the information from the previous time step or forget it. The last one is the output gate that controls what information is output from the memory cell. Here, the activation function is the hyperbolic tangent, and the token with the maximum score in the output is chosen as the prediction value. The LSTM network has been optimized by using continuous particle swarm optimization with the aim of selecting the minimum number of neurons in hidden layers and to minimize the learning rate. CPSO is a continuous formulation of the standard particle swarm optimization that has been proved accelerate the convergence of the swarm toward the global best position. It is realized by updating the particle position as a solution of this Cauchy problem described by a second order ODE. Oh, sorry, here in the blue box. Physically, it describes the dynamic of a damped harmonic oscillator with omega that represents the undamped angular velocity of the oscillator and zeta, the damping ratio. And they have to satisfy the following conditions that allow us to rewrite the previous problem also in this form. The solution is obtained as a piecewise function because the time interval is subdivided into sub-intervals where both zeta and omega are constant. And with a proper assumption of the initial condition of these local systems, we can ensure that the solution is also a continuous function. Another attention is on the eigenvalue of the associated homogeneous ODE, because it allows us to distinguish 3 different subcases, which are the critical damped system when zeta is equal to 1, then under-damped system if zeta is less than 1, and the last one, the over-damped system when zeta is greater than 1. It is necessary to consider these subcases because on this case depends the form of the solution. This is the case of under or over damped system, and this is the case of critically damped system. Okay. Here we have the flow chart of the neural network model that has been modified within the introduction of continuous particle swarm optimization, as you can appreciate here. that is in the training phase. And as we said, it has been introduced in order to optimize the number of neurons in the hidden layers and also the learning rate. The presented procedure has been applied in a real case study, and that is an area characterized by various traffic attraction poles, that is via Boris Giuliano in Enna. The data has been collected, the data for the training of the neural network have been collected in a week from 6 a.m. to midnight with 15 minutes slot. Two survey stations at the beginning and at the end of the road have been located. These are the parameters that have been chosen in the simulation of the real case, and also the objective function adopted for the ICCSA procedure, that is the mean square error. And in conclusion, you can see the plot, so the behavior of two functions, which are the RMSE, the root mean square error function, and the loss function. Both of them represent the difference or the error between the prediction vector and the vector we can use for a comparison. So that could be the real data in our case. Without the optimization process, the RMSE has a minimum value that is about 0.6, while the loss function is about 0.2. When the CPSO has been introduced in the training phase for the neural network, the RMSE reached a value that decreased to 0.4 against 0.6 in the previous case, as well as the loss function minimum that is now 0.1 against the 0.2 in the previous phase. The neural network has been, the training of the neural network has been realized in 3 days of in the data of the first 3 days of the week that has been collected, and then the other data, collected in the last 3 days has been used for the comparison of the prediction, and this is the result. We can note we have the representation of the prediction values together with the real data, and the figure show in this comparison the good agreement in the prediction of the model that has been implemented. And so that's all. Next step is to adopt the same procedure to the new cases in Parma and Cagliari, and we are working on it. So that's all.
So we will see the result in the next
time.
Okay, thank you very much, Angela. If there are specific questions for Angela, yes, we have a question for you, Angela. It's better if you come here because she has to listen to you.
Hello, Francesco Misso, Bibutech. Thank you very much for your interesting presentation. I'm dealing with projects about mobility and analysis of demand and offer, and so we can see different contexts in Italy mainly, but not only. My question is, in your case study, we saw a context about urban area specific, if I understood well, a specific urban road, no, in Enna.
Yes.
And
Yes.
my question is it possible to think to extend this concept to a macro area or an area wider than one specific urban roads? Because
Yes.
we are users of modeling tools, and we know limits and advantages of the tools already available. So it's very interesting to think beyond the tools today available.
Well, I think that it could be possible. Of course, it depends on the kind of data you can collect and all the information you can add in the training procedure. And this kind of procedure can be, for example, applied also in the case of in the study of water distribution system that is as complex as a macro area in urban context. So we are working on it, and I think it could be.
Mm-hmm. Okay. Thank you. Thank you.
Thank you, Angela.
Thank you for your question. Thank you,
I
Silvia.
think that we had a quite interesting presentation today because we see several different approaches, several different methods to assess cities and urban areas, but with let's say a common goal, so a common aim. So the aim to make our cities more thriving, more sustainable, and more enjoyable. So I'm very happy about the results. I have also some news for the online colleagues. They told us that all the proceedings have been published. So each of you will be able to download his own chapter soon, but they are already online. On submission side, so we can have a look. And if we have other comments, otherwise, can I ask every one of you to switch on the camera so we can have a picture all together? So Gloria, Serena, Vincenza, who wants? I mean, you are not, we do not force you, but if you want to turn on the camera, and also with in presence colleagues. So we have to find a way, I mean, to sit down, and I will have a picture for you, but then I make a picture of you. Okay. So this is the camera, so we can sit here. Melba, no, see Gloria, Serena, Vincenza.
I'm Serena.
With two phones. Okay, you ready? 1 second. Okay, ready?
Yeah. Okay, thank you. Thank you all. So thank you very much, everybody. I think that now we have to move for the next steps of our conference, but we hope to see you all in presence very soon.
Thank you so much. Bye.
Bye. Bye. Bye.
Thank you very much. Bye.
Bye.